If you've ever played with a compass, you know the rule. That tiny needle always swings back to point north. But what if I told you the needle is lying? What if the north it's obsessed with is not only constantly moving, but is also technically the wrong magnetic pole? Is this a glitch in the matrix? A secret we've been taught wrong since grade school. We're going to peel back the surface of the Earth, literally, to reveal the colossal, violent, and utterly vital engine running thousands of miles beneath your feet. It's the force that guides every lost hiker, every commercial airliner, and protects every living thing on this planet. Yet, it's far less stable than you think. The foundation of this entire mystery is simple, but staggering. The Earth itself is a gigantic, roaring magnet. It creates its own magnetic field, an invisible, complex bubble of force that stretches into space. So, how does a giant ball of rock and metal generate such power? The answer lies in the geodynamo effect. Deep down is the Earth's solid inner core, mostly made of iron and nickel. Surrounding it is a liquid outer core, an ocean of molten metal, so hot it's constantly swirling and churning. Because these metals are excellent electrical conductors, their massive movement generates electric currents. And as physics dictates, whenever you have electric currents, you get a magnetic field. The Earth is essentially a colossal, perpetually running electrical generator, and the molten core is the fuel. Here's the first mind-bending twist that always sparks debate. The north your compass points to is magnetic north, not true north. True north is fixed, the geographic top of the Earth's axis. Magnetic north is a moving point on the surface where the magnetic field lines plunge down into the planet. And that's not the worst of it. The north pole of your tiny compass needle is attracted to the opposite pole of the Earth's giant magnetic field. This means the point we call the magnetic north pole is actually a magnetic south pole. It was simply named magnetic north because it resides in the northern hemisphere. Your tiny compass needle is constantly pointing its north pole toward a massive magnetic south pole. This is a scientific loophole that makes everyone stop and question everything they know about basic navigation. If you imagine magnetic north as a fixed marker, you are deeply mistaken. It is on the move. The wandering pole problem is so pronounced that over the last century, magnetic north has drifted more than 600 miles from northern Canada, hurtling toward Siberia. For a family taking a short hike in a national park, this drift might not matter much. But for a trans-Atlantic pilot, a Navy submarine, or a land surveyor drawing property lines, a few degrees of error caused by moving magnetic pole can result in millions of dollars of lost time or catastrophic navigation failure. That's why serious maps include a measurement called magnetic declination, a cheat sheet telling you exactly how far off the compass is from true north at your location. The world's elite navigators are constantly tracking this silent, invisible shift. The magnetic field is not just a guide, it is an absolute necessity for life. Think of it as a massive, invisible force field, a global defense system. The sun constantly spits out lethal streams of charged particles called the solar wind. Without our magnetic field, those particles would slam directly into our atmosphere, stripping it away over time, much like what happened to Mars, a planet that lost its magnetic dynamo billions of years ago. Our field deflects the vast majority of this solar wind, protecting our breathable air and shielding our fragile technology and satellite networks from being instantly fried. It's the ultimate behind-the-scenes bodyguard. What happens when those charged particles manage to breach the defense system? They are channeled by the magnetic field lines down toward the Earth's poles. When they collide with the gases in our atmosphere, oxygen and nitrogen, they cause them to glow, and known as the aurora borealis and the aurora australis, The same magnetic energy that keeps a tiny compass needle steady is also responsible for painting the sky with one of the planet's most beautiful natural light shows. It's the defense system's celebratory fireworks. Here's the most alarming fact about our magnetic shield: it flips. North becomes south, and south becomes north. This happens irregularly, roughly every few 100,000 years. The last time this catastrophic reversal happened was about 780,000 years ago. In geological time, that means we are statistically overdue for another flip. During this reversal process, the magnetic field temporarily weakens, potentially dropping to just 10% of its normal strength. A weaker field means a thinner shield. This scenario would expose us to significantly more solar and cosmic radiation, disrupting everything from global communications and power grids to wildlife migration. While humanity has survived past flips, a flip in the modern, technology-dependent world is a terrifying prospect that scientists are actively modeling. You interact with this colossal magnetic force every time you open your laptop or tap your phone. Magnetism isn't just about rocks and compasses, it's the quiet power behind the modern world. The tiny speakers in your phone and headphones rely on magnets to create the vibrations that produce sound. Your computer's hard drive uses magnetic storage to save every photo, file, and document you own. Even specialized medical equipment like MRI machines, used to diagnose and save countless lives, are essentially giant, powerful magnets, generating detailed images of the human body. The same fundamental principle that guided ancient Chinese mariners across the Pacific is also what lets you pay for groceries with your credit card or watch a show on a streaming service. Could we have our own magnetic sense? There's fascinating, controversial evidence that humans might have a biological sensitivity to magnetic fields. Scientists have discovered magnetite crystals, tiny, magnetic minerals, in the human brain, similar to those found in migratory animals like sea turtles, birds, and salmon. This doesn't mean you can close your eyes and instantly find true north. But it does raise a profound question. Did our ancestors once possess a forgotten magnetic sense? Was this part of our evolutionary toolkit, lost over time? Imagine having that ability reawakened. You'd never need a map or a phone GPS again. Let's dive into some truly strange magnetic facts. The strongest magnets on Earth aren't found in nature. They are made in labs for high-level physics research. Scientists have created electromagnets powerful enough to generate fields many thousands of times stronger than the Earth's. One famous experiment used such an intense field that it was strong enough to levitate a frog, defying gravity through the power of magnetism alone. The lesson? This invisible force is not only colossal on a planetary scale, but can also be manipulated by human ingenuity to create unbelievable, gravity-defying effects on a tiny scale. So, the next time you hold a compass, remember that little needle is the physical, observable link to the colossal, churning heart of our planet. It's not magic, it's an invisible, violent, and absolutely vital connection. The Earth's magnetic field is a silent guardian. It protects our atmosphere, deflects solar radiation, guides every traveler, and paints the sky with the most spectacular light show in the universe. It's a 24/7 force field that we rarely think about. This force links ancient explorers with modern astronauts, survivalists with scientists. It is the final, profound handshake between the tiny world in your hand and the restless, molten engine that powers our planet's magnetic soul.